Okay, so here's your server socket. So over here, this is the server side, right? So it's doing an accept. And here's client 1. Tries to connect to, right? So you've created a socket. Accept will come back and it'll return a socket, and this socket will be connected to each other. Okay. Now if you say accept again, and another client 2 creates a socket and tries to connect to the server, accept will return a new socket which will be connected to client 2 socket.
What more do we say, like, when we have 5 servers, it will be on the same router, how do we know which server to connect to that's ours?
5 servers running.
Is that possible?
So each server would have its own port, right?
Okay.
So if somebody else is sitting on their machine and they're running something which says, here's a server at port 1220, right? Or their own IP address. So you're running a server and I'm running a server,
Yeah.
right? We can both be running a server on port 1220, but my machine is 2.3, his machine is 2.5, right? So depending on which one you connect to, when you do this client-side socket, we'll tell you which one. So on Windows, you can say IP config, I believe,
Oh, yeah.
or a DOS shell. And you gotta be a little careful how you do this. So on Linux, you can say IP address show. And this is the internal address, 127.0.0.1. But so this is your wireless connector. And this is the address on that wireless network. So that's the address the router sees.
Okay, and where's the port? I don't see the port.
The port was specified here when I created a server socket.
Okay. Okay, I see.
You can also do a netstat, and you can say -A to show active connections, -N to show numbers instead of names. And if you look in here and find your port 1220 somewhere, watch, it won't show up. Oh, there's 1220. Oh, it doesn't show me the address. Oh, that's a bummer. Oh, because no one's talking to it. It's just listening right now. So there's the active connection. Right, so it's established. That's the socket number of the client. That was the server socket, but that's still just a local address. So ifconfig is your other option. Like I say, on Windows you can do ipconfig from a DOS shell, and that'll show you. Or there's probably other things. Linux, I would think ifconfig would work also on a Mac. I crashed my machine. Don't worry about it. All right, so play around with that if you want. How many people are doing PA5? How many people are planning to do it?
Oh, okay.
Okay, cool. Awesome. Like right this moment in your head.
Probably has is optional.
Say what?
The PFI, everyone has to do
Oh yeah, everyone has to do it. Never mind.
it. Yeah.
I think you meant lab.
Only the lab.
I'm in Lab 5, yeah. So how many people are doing Lab 5? Almost everyone too, good. Okay.
We'll figure it out.
All right. So questions on PA5 networks, router, servers? You're good to go? Yeah. All right. So various things I want to go through this week. Next week, Monday, we're going to start presentations on PA5. And I'm guessing that'll probably take a couple of days, depending on how many people are in groups and so on and so forth. And then we want to do some review for the final. And if we have any time left over, we'll pick up some extra things. So we've mainly got this week. So I want to talk about a bunch of things. I want to talk about the URL class, because that's a fun one to play with. I want to talk about jar files. And I want to talk about class paths. These are just mechanics that you want to know when you're dealing with Java. And we've been using them without necessarily knowing what we're doing with them. But ways to take multiple classes and bundle them into a single object and then point your Java compiler or the JVM to that collection and say, if you need a class, look in here for it. And it lets us move things around, make them portable and so on. So I want to talk about jar files and class path. I might talk about speech as an example of that. So we'll look at a speech class to make our Java programs talk as an example of using a jar that's already bundled for us. I may talk about Android, because Android is basically Java. It's a different set of classes, but you can make a drag and drop interface that shows you what your phone or your tablet's going to look like and drop components into there and hook them up to actions. And it feels very much like what we've been doing with Java and with Swing, but applied to creating apps for Android. So we may do that. And there's some other stuff that we'll go through. So we're just kind of picking up things at the end here. But like I say, as far as programming, I think everybody's in good shape right now. So we can do a bit of playing. So URL is a class that basically gives you access to things on the web. My machine's not happy today. So you construct a URL by giving it a universal resource locator, right? Like typically an HTTP string. So I'm just pointing to my web page on the Linux server. And once you have a URL object, you can say OpenStream, which creates a connection to the web server in this case on this host. And once you get the return from OpenStream, you can construct an input stream reader from that. And with that input stream reader, as usual, we can construct a scanner. So SC will give us access to whatever is coming from the web server at that location. And I am going to need a network connection for this. So let me disconnect here and connect. See if I can trick it into connecting. So here's my web page on the Linux server. So it's a one-liner. And here's the HTML that produces that page. So everybody here familiar with HTML? Basically, it's just a markup language. So the things in angle brackets specify how the information should be presented. So HTML says it's an HTML file. The title says make hello look like a title, and then slash title is the end of that block. Everything gets sandwiched by body and slash body. In the middle is just the text we're going to see. So that produces a page like this, and hello comes up on the tab because that's what the title is, and this is just text. So I'm opening a URL, constructing a URL object on that same web address, creating a scanner, and then our usual loop. Well, there's another line coming from the scanner. I call next line, save that as text, and I'm just going to print it out inside angle brackets so we can see what's coming from that web server. And if we run this, we get a list of that HTML.
Oh, it doesn't give you the body of the file, it gives you HTML.
Gives you the HTML. That is the whole thing that the server is sending you. Now your web browser interprets the HTML and uses it to display the web page you see.
Good job, Facebook.
Yeah, totally. So we have not found, it's shouting at me. Yeah. It's gonna be one of those days, that's okay. I was up since 2 in the morning, so. So there's the code area I've been dropping stuff in, right? And there's a rectangle directory, and it's got Java code, right? So Linux engrcs.com, twiddleneck shared 223 rec.java. So if we use that as a URL, right? So that's the resource we're trying to fetch. We open up a stream using that address, construct a input stream scanner, go ahead and read it. When we run this, well, there's the contents of that file, right, which is not HTML, it's just a text file containing the sample rectangle code. So you can grab whatever you want effectively from the web inside a Java program. Right? As long as you have access to it from a browser, you have access to it from here, and it's a few lines of code to grab that. So that's kind of cool by itself, right? And if you want to play around with serving web pages, right, this is one way you can automate the client side of it. And this is a client-server model, right? So a web server is kind of a quintessential server. It listens to a port, usually 8080 or something else, and waits for connection requests. And this is going out to a port on the destination machine, Linux engrcs.com here, and speaking a simple dialogue by which it requests different pages, and the server sends them out. Yeah.
You're able to write from here too, right? You're not restricted to just reading, or is there a restriction on that?
So, yeah, theoretically, but you don't really write to the server in that way. You can do like put requests, but they're usually fashioned as access requests, right? So give me this page, but embedded in that address that you request are usually question marks and then fields over there. And it's a code to say I want to set variables to certain values or fill in a form or things like that. So if you know the whole language of HTTP, you can do all this stuff from Java. So that's potentially cool and useful. So here's something similar built with Swing. So I've got a Go button, and I've got a web pane, which is really a JEditor panel, right, or a JEditor pane. and that's sitting inside a scroll pane. So if I try to put more stuff than fits on here, I'll get scroll bars appearing automatically. And a JEditor pane is really useful. So it's a text component to edit various kinds of content, look at the constructors, and you can build this thing using a URL. So the code for this is going to do the following. Oh, can't zoom in, that's okay. And most of this was auto-generated, right? The main method was auto-generated. The only real code was the Go button. And so the Go button is going to do the following. It's going to construct a URL, again on twiddlenick/shared. And then it uses a method called setPage on that JContent pane. So setPage to URL, I set editable to false. And that's pretty much all it does. But if we run this, we get our window, and when we hit go, there's a copy of my shared page, which gives you links to all of the stuff in the shared area.
So you're like one step away from like making a browser.
So you're one step away from making a browser. And down here, we have code for something called Hyperlink Update. And if you look at that code, what does it say to do? Well, hyperlink, that's the underlying things, right? There's a hyperlink listener. And when something happens with that link, when you hover over it or you click it, you're going to jump into this piece of code. It passes an argument, which is an event. I can use getEventType and see if that's equal to activated. And if it is, it means you clicked on that link, in which case I say getURL. That's a method for the hyperlink event, which will give me the URL of whatever it is you clicked on. I'm going to print that out with the message click, and then I'm going to say set the page to that URL. So when we run this and we say go, we've got our directory here. We can scroll. I can click on 223 and it follows that link. And I can come down to print writer and it'll follow that link, and I can go to main.java, and there's main.java. So you can do a web browser in like 12 lines of Java code, right? Because all the smarts for doing that are embedded basically in the content pane and in this event, this hyperlink event. And from that point, it's just code, right? It's just programming. So I print out a click message with this arg0 getURL. Here's exactly what getURL is returning, right? Any reason I can't just throw those things on a stack and give myself a back button? And then every time you click back, just pull off the last thing that you pushed on the stack, use that in the setPage method, and now you're going backwards. You can record history, all these things that browsers do, right? They're trivial. It's just coding. And this is kind of the nature of a lot of programming and program development anymore, right? The things that actually make it work are not terribly complex anymore from a programming perspective. What's going on underneath is very complex. But in terms of how would I change this code to record a history of the last 100 pages that you visited and make them available in a drop-down list, it's nothing, right? You just throw these things in an array, and when you click on the history button, put up a content pane and just list them there, you know? But it's because there's so much machinery behind all of this. There's the whole web itself, and there's all these classes that know how to talk to it, and there's the whole idea of doing socketed communication and talking to servers from clients and things like that. and you get to just kind of like use that how you wish, and put together things according to your imagination. So this is where programming, for me at least, gets really fun, right? Because you've got the know-how and the tool set and the language to manipulate all these amazing things. Anybody who was at the ECS club meeting on Friday and heard the talk on Alexa, right? Same thing. I mean, it's not a whole lot of code. Python was the example he was using to get to where you can interact with this whole command and control system. So this is good stuff.
That was actually
Right?
one of the things I was thinking of as you were going through
Yeah.
this, is that's what it was reminding me of.
Yeah. And if we get to looking at Android later on this week, right, you'll see the same thing. We can make an app on a phone or a tablet, and you can tap into GPS and send an SMS message to someone with your coordinates every 15 minutes or something, right? And it's just code. It's really nothing more. All right, so that's the URL class. That's good to know. JContent pane is good to know. Questions on that? Let me peek at my list. All right, let me show you one more example. That was glorious. That's better. So this was some work I was doing mostly over the summer last year. And it was a learning system, and the goal of this particular set of experiments was to try to evolve a system that could learn how to control a little spaceship and make it land on the moon. Anybody ever play Lunar Lander? Like a really old ASCII-based video game originally. You basically have a ship coming down to the surface of the moon. You control the thrust, right? Basically turn it on or off, and you try to get it to land smoothly. So I had the system that was doing the evolutionary work, right? It was a genetic algorithm. It was going through, thousands of variations on genomes to try to build a control system. And then it needed to know how well each of these systems actually did at landing this ship on the moon. And I didn't want to bundle all of the code for the landing simulation into the evolving part. And I also wanted the option of getting a visual display of the landing as it was going, because I thought it would make good video fodder for later on. So this was a classic case of using a client-server model. So the evolutionary code is sitting here. It's doing all the hard work, and that's acting like a client. And there's a server, which you're seeing up here, which is responsible for simulating the movement of this ship. And the client can send instructions to the server, and the server can send information back. And this gives you a nice separation, right? Because this thing is slow and it's expensive, and I didn't want that to be bound to the actual code that was doing the evolution. So we can mimic this by connecting to, so you can put in your port number of choice here and say start. So we can connect to port 1213. And it's a simple one line per command dialog. So for example, if I want to turn, if I want to step the simulation, I can just say S, and it updates the speed and the altitude. So it's starting at an altitude of 200, and it's slowly descending, but the speed is picking up. And after a bit of this, you can see it start to move. So it's actually coming down now, and the speed's increasing. It's a small time step. And now you think the speed's too high, so you want to turn on the thrust, so you can send a thrust command, and you get the little thrust symbol coming out there, and you can start stepping the simulation further. And if you want to know what's going on, you can say dump, and it will send back to you structured information telling you the simulation is not done, your fuel is 199.75, your speed is -16, your altitude is 179, right? And this is just, right, this is a format that I thought I could use. There's nothing special about it, it's just a print line statement in the server, sending it back through the socket. And so you can keep going like that, and if you give up, you can reset. You go back to the beginning. You can also spend a command to initialize it to a certain amount of fuel, speed, altitude, and thrust setting. But the advantage of doing this, like I say, is that all of this stuff with the graphical display and swing and all of that stuff is like totally separate, right? And it doesn't have to be graphical. I could write something that just does a quick simulation. I could write it in C if I wanted it to be really fast. Or I can just have a switch and say, don't send anything out through the socket. And now it runs in a headless mode, and it's just really fast. But it's kind of a typical use case for where this client-server setup can be useful. And I probably do this more than I should, but it just seems to always come up as a nice way to separate out behaviors in larger systems.
Yeah, as long as you're not distributing the program, it seems like a great solution.
Well, so I had another one for a virtual ecosystem with a bunch of organisms moving around that were being controlled by this thing. And that one I actually did distribute. I bundled it up in a jar file and sent it to a friend in DC. And she had a computer that wasn't being used and just kind of set it off running and went a little crazy with it, which was cool. So we'll get back to that later this year. But yeah, so this stuff actually gets used, right? And it's not just to talk to a web server or talk to a login server or something. You can make your own client-server pairs whenever it makes sense. And it cuts across languages, right? You can do this easily from Python, you can do it from Perl, you can do it from Java, you can do it a little less easily from C. You can do it very non-easily from assembly language. And you can do this on a Pi, you can do this on an Arduino, right? You can do this on an IoT device, and it's all the same protocol. It's all sockets, and we're talking about TCP/IP sockets, and most devices understand that today.
You could do it in binary.
You could do it in binary, yeah. You just toggle in the ones and zeros. All right, so I'm going to talk about jar files tomorrow, and sort of the mechanics of dealing with large numbers of classes and how to put those together into a single entity. I'll look at speech class. And the other thing I want to talk about this week is C++. So maybe we'll start on that tomorrow, definitely Wednesday, if not tomorrow. Just go through some of the basics of C++, look at some examples of how you use classes in there, compare and contrast to Java. I also want to look at operator overloading, because C++ will let you do things like make your own function called plus. So you can say A plus B and it'll run your code, which is kind of nice. All right, so we'll continue with this tomorrow.